Yes, welcome students. I am really happy to see you all of you here. In this class, we are going to talk about an assignment problem. And the assignment problem can be solved by Hungarian method. Here, a problem is given to us. Okay. So what is that particular problem? Okay, let us discuss that first. Now, uh, wait please. I will bring that to your view. Okay, this is what assignment problem. Still I want to maximize it. Yeah. So this is what the problem given to us. Raja, Gobi, John, three persons or workers given three jobs: carpentry, electrical, and water. Okay, carpentry, electrical, and water. They are asking the figures inside the box as the salary, as the remuneration for doing that. Take for example, John to do the carpentry asking 15 rupees. Gopi to do electrical work, he's asking 7 rupees, and Raja demanding 12 rupees to do water work. Okay, if that is the case, uh, so how to decide the assignment? I mean, which person should be given which job so that the total assignment cost is very, very minimum. That is what our aim. Okay, let me do by Hungarian method. In the Hungarian method, the first step is that we have to see whether the given problem is a balanced problem and unrestricted problem. Okay, so you see the problem given here. Definitely, this is a balanced problem because there are three rows are there, three columns are there. In real fact, three workers are there, three jobs are there. Therefore, it is a balanced problem. One more thing, there is no condition, there is no barrier that we cannot assign this person this job. Such data is not given here. Therefore, the given problem itself is a balanced and unrestricted. So the first step is over. The given problem is already in already made. It is a balanced and unrestricted. Coming to the second step, it is a row-wise reduction. Okay, row-wise reduction we say. We know what is a row-wise reduction because in another video I was discussing about that. So row-wise reduction. Okay. So row-wise reduction means what? Okay. Now look at that. The given matrix given to us. First row we are taking what is the least number. You identify that and you subtract that from all other entries in the corresponding row. In the first row the least number is 5. So subtract this 5 from all other entries. What you will get? 10 minus 5, 5. 0 minus 5, 0. 12 minus 5, 7. Do the same for the next two rows. In the second row, the least number is 3. 3 minus 3, 0. 7 minus 3, 4. And 11 minus 3, 8. Come to the last row, the least number is 5. Subtract that from all other entries in the corresponding row. 15 minus 5, 10. 5 minus 5, 0. 6 minus 5, 1. And this is called row-wise reduction. This is the next step number 2. Okay. Now what about step number 3? The step number 3 is column-wise reduction. What we have done row-wise, the same thing we have to do here column-wise also. Okay. Now from the second step, this is row-wise reduction. You take the first column. Okay, first column you take. In the first column, I am taking the first column here, which is the least number. 0 is the least number. Am I correct? The 0 is the least number, right? Subtract this 0 from 5. 5 minus 0, 5. 0 minus 0, 0. 10 minus 0, 10. Okay, right. Come to the next column, which is the least number. 0 is the least number. 0 minus 0, 0. 4 minus 0, 4. 0 minus 0, 0. Come to the last column. The least number is what there? It is 1. So subtract this 1 from this 7. 7 minus 1, 6. 8 minus 1 is 7. 1 minus 1, 0. Okay, and this is called what is called column wise reduction. We say it is a column wise reduction. So first step is that we have to bring to the normal stage, that is balanced and unrestricted. It's already, therefore no problem. Second step that we have to do row wise reduction. Third step is that we have to do the column wise reduction. Okay. The next step is about drawing lines through maximum number of zeros. That's what we have to. We have to draw the lines through maximum number of zeros. That is what the next stage. Okay, right. If we come to this particular stage, here we have to draw the lines across the maximum number of zero occurring rows or columns. Maximum number of zeros occurring rows or columns. Through that we have to draw the lines. Now in this particular matrix structure, the maximum possible zeros are 3 zeros. Okay, maximum possible zeros are 3 zeros here. Sorry, here it is not like 110. That is what look like comes here. It is not 110, it is 10. In this particular box, the maximum number of possible zeros are what? Possible zeros are 3 zeros. Okay, so first we are searching for each row for 3 zeros, then each column for 3 zeros to strike out. First you see the first row, no, only 1 zero is there. Second row, only 1 zero is there. Third row, only 2 zeros are there. First column 1 0, second column 2 0, and last column only 1 0. So next maximum possible zero occurring rows or columns are only 2 zeros. So let us search for 2 zeros rows or columns. First row only 1 0, second row only 1 0, but third row you see there 2 zeros are there. I am striking out and giving number line 1 or first number line or first line like that. Now come to the next one. Column wise there is no 2 0 here, no 2 0 because this 0 already striked out, therefore this 0 you should not take into account. So only 1 0 here, also no zeros there. So next to possible maximum 0 is only 1 0. Okay, so first I am coming row wise. Is there any 1 zeros are there? Yes, 1 0 is there, so strike out, that is number 2. And next row also have only 1 0, so draw the lines, then that is number 3. So how many lines we can draw? 3 lines we can draw across the rows or columns. Am I correct? Now next step is that about checking whether the number of lines equals the order of the matrix or not. Look at that. The given problem is of order 3 by 3. Now how many lines we have drawn here? We have drawn 3 lines here. Am I correct? Therefore the number of lines equals 3, order of the matrix also 3. Now look at the given problem. It is 3 by 3. Am I correct? So order is 3. The number of lines equals 3. Therefore the optimum is reached. Optimum is reached. Okay. Now once your optimum is reached, what is our next stage? Our next stage is that we have to make the optimum assignment. Optimum assignment for the job to optimum assignment for the job to the persons. Okay, now this is what step number 6. So we have to do optimum assignment. We have to do here. Okay, so how to do optimum assignment here? Now look at this. Okay, now there is that particular box. I minimize that. Okay, so in this particular box in the step number 4, only 0 assigned place only you take. Okay, only 0 assigned place you have to take into account. 0 assigned place. So here 1 0, take that 0 here, take that 0 here, here another 0, another 0, here another 0, another 0, last one another 0 here. So only 0 occurring cells only you have to take. You should not take this cell, non-zero cell, non-zero cell, non-zero cell, non-zero cell, non-zero cell. Only these 4 cells are 0 cells. Okay, so that you have to take into account. Now what next? We have to assign such that each row have only one assignment and each column have only one assignment. Okay, each row should have only one assignment and each column should have only one assignment. Such a way we have to assign. That is called optimum assignment. That is step number 6. So step number 6 is optimum assignment. How we can do that? Now look at that. In the first row, that is first person I am taking there. For the first person, I am assigning this job because only one possibility are there. If I assign this, I cannot assign this to this particular person because one person can be assigned to only one job. One person can be assigned to only one job. Therefore, this person I am assigned to this job. Therefore, here I cannot assign. Therefore, I am striking out. Similarly, if any other zero comes here, we have to strike out them. Okay. Come to the next row. In the next row, only one zero is there. I am assigning that. Okay. So second person has to take the first job. First job he has to take. Right. So no possibility assignment, other possible assignment there. Suppose there is a zero comes here, strike out. Zero comes here, strike out. Zero comes here, strike out. 0 comes here, strike out, in order to satisfy the condition that each person should have only one job. Coming to last one, this is already striked out, only 1 0 is there, assign that. So this is the best assignment. Mathematically, definitely this assignment will give the optimum assignment cost for us. That is minimum among minimum. We cannot find the assignment cost which is less than this. That's called minimum among minimum. Okay. So what is the factor here? The first person should be given to second job. Second person should be given first job. And the last person should be given last job. Okay. You go back to our problem here. So first person Raja should be given to the second job, electrical job. Gopi should be given the first job, and the John should be given the last job. Am I correct? That's what the assignment here. Look at that. The first person should be given second job. So who is the first person here? Raja should be given electrical work. Okay. So actually here, who is he? Raja. Who is he? Raja. Raja should be given which job? The electrical job. The second person. Who is the second person? So let us second person here is Gobi. Gobi should be given first job. Gobi should be given first job there. That is Gobi. Gobi should be given first job. What is our first job? Carpentry job. Okay, right. The next one, who is he? John. John should be given the last job. What is the last job? A water job. Am I correct? So that should be the correct assignment for us. Okay, and that's what we have to understand here. So that's what is given here. It is given here. Therefore, this is a best assignment for us. Okay, so Raja should be given electrical job, yes, and Gobi should be given the carpentry job, yes, and John should be given the water job. Okay, so this is the correct assignment, best assignment for the given problem. If assigned so, what would be the minimum transportation cost? Go back to the problem there. If you go back to the problem, you will understand that Raja is given to electrical job. He is asking 5 rupees. Am I correct? So 5 rupees Raja is asking. Plus second person Gobi should be given first job, carpentry job. If she is allotted 3 rupees we have to give. Okay, plus the last job. Last job should be given whom? To John. Which work? Water work. How much? 6 rupees. So what you will have total amount as here you will have 8 plus 6 14 rupees. So 14 rupees is the total minimum cost. Okay, so minimum or optimum cost for this particular assignment problem is 14 rupees. Thank you very much. And so thank you very much for being with me. Okay, so this is what the problem about. So minimum is that equals this is what 5 rupees for assignment of first person Raja to the second job, electrical job, and this is the assignment for Gopi for accepting carpentry shop, and last one 6 rupees. John accepting the last work, water work. If all of them are together, the total cost is rupees 14. 8 plus 6 14 rupees. So 14 rupees is the minimum cost with which we can assign all these person to different jobs. Okay, so with that we have to come to the end of this problem, and the next session I will be coming with another problem. Okay, so thank you.